Hey, good morning, everyone. We'll get started soon. All right, Toby, do you think we're good to start with the presentation?
Yep, I think so.
Okay, cool. Hi, everyone, welcome. Today we're talking about Nomad for Kubernetes practitioners. My name is Iris. I'm a SRE at HashiCorp. And I use she, they pronouns. So some motivations for today is just my experience learning Nomad after working with Kubernetes. So I worked with Kubernetes for 2+ years in a production environment and Nomad for less than a year in a production environment. And it was a little tricky for me to make the switch. So I wanted to share some of my experiences, also just like talk about both of them. And another motivation is just community interest in Nomad. So here's a screenshot from Hacker News front page. It's a blog post from Karan Sharma about running a home Nomad server. And it's a good blog post. Also, I enjoyed reading some of the comments in the Hacker News thread about people's experience with Nomad and Kubernetes. Okay, so here's today's agenda. We're going to talk about some core comparisons between the two, and share some like reflections about working with both or learning Nomad after working with Kubernetes. And we'll go through getting started with Nomad. So we'll spin up a Nomad dev cluster, and then we'll deploy a job to the dev cluster locally. Okay, core comparison. So this is going to be pretty broad overview. Okay, so bird's eye view, Kubernetes is a container orchestrator that includes service discovery, secrets management, and so on. It's quite robust in its feature set. Those are obviously not all the features that are included with Kubernetes. Nomad is a workload orchestrator for containers, batch processes, and so on. And it's single purpose. So we would deploy it with Vault for secrets management and Consul for service discovery. Okay, so just more about the architecture. We'll start with the Kubernetes node. So if you're familiar with it, it consists of kubelet, container runtime, kubeproxy, and the kubelet is the agent that makes sure pods are running and registers the node with the control plane. And container runtime is the software to run containers. Docker is popular container runtime. And kubeproxy is a network proxy that runs on each node. And Kubernetes deployments run on nodes. And then Nomad, we have a Nomad client, which is running the Nomad agent in client mode. Nomad agent is a binary you would install on your node or your server. And all you need really to get up and running is a Nomad agent. Here we list task drivers as optional. So task driver would be Docker or Java, for example, or exec. And then Consul agent is optional for networking and Ingress and whatnot. But typically you would want to include some sort of task drivers if it's not already pre-installed on your server. And then in production, you'd probably want to install the Consul agent. Okay, and so for the Kubernetes control plane, so these are components of the Kubernetes control plane. Kube API, server exposes Kubernetes API. etcd is the key value store for cluster data. Kube scheduler schedules pods, and the Kube controller manager runs controller processes, so like node controller, job controller, and so on. And so Nomad Servers, so this would be running Nomad agent in server mode. So again, just need that one Nomad agent binary. And so what it does, it includes a scheduler and resource manager built in, and it manages cluster state via Raft. And again, the console agent is optional, but you would include this in the production deployment. So here's some comparison of like what production deployments would look like in Kubernetes and in Nomad. Yeah, Kubernetes cluster would consist of control plane nodes and worker nodes. So it's like a hub and spoke API pattern. Each node has a kubelet running, which is primary node agent, and the kubelet self-registers a node with a control plane. And the control plane communicates with the worker nodes via API server, kubelet, or the node's pod services directly. And pods are scheduled to run on the worker nodes. And again, etcd for distributed key value store, which runs on the control plane nodes. So in a Nomad cluster, this would consist of Nomad clients and servers. Nomad servers participate in Raft, so they keep cluster state. And then client nodes forward requests to the servers, and communication between nodes happens via the gossip protocol. For production, we would deploy node with console for service discovery and dynamic config. So a console agent would be installed on each Nomad server and client. And so with Nomad, there's a server leader, and then there's server followers. So you have to have essentially a odd number of servers, and leader election happens. So with Kubernetes, there's no leader election happening, no control plane leader, essentially. Okay, and so let's get into units of work. So the smallest unit of work in Kubernetes is a pod. So these are co-located, co-scheduled containers. And tasks are the smallest unit of work in Nomad. So tasks can be containers, web apps, batch processing, and then co-located Nomad tasks are called a group. Okay, so this is around scaling, really. Replica sets maintain a stable set of replica pods. These are baked into the Kubernetes deployments, which we'll touch on in the next slide. Task groups are co-located tasks, which I mentioned earlier. And this is where you specify the number of tasks that should be running in the group. And so these aren't one-to-one features, but I'm showing them side by side, as this is where you would configure the desired number of your pods or your tests. Okay, and so more units of work. So Kubernetes deployments and Nomad jobs. So Kubernetes deployments are declarative specs for pods and replica sets, and Nomad jobs are declarative specs of tasks that Nomad should run. again, these are not like one-to-one, but they're fairly similar in concept. Like I would deploy a Kubernetes deployment or a Nomad job if I wanted to do certain things with containers. Okay, on to networking and service discovery. So Kubernetes service, it maps services to pods labels. Kubeproxy implements virtual IP for services and forwards the traffic from services to pods. And there's add-on DNS service. And for Nomad, we would use a console client agent. So in this case, the Nomad service is registered with console via the service stanza. So there's a concept of service in Nomad as well. And console would provide service discovery, DNS, and some basic load balancing. Okay, next, talk about some load balancing in Ingress. So with Kubernetes, you can set your service type to load balancer and provision a load balancer for your service. There's a Kubernetes Ingress resource. You need to use this with an Ingress controller. Some examples, Nginx, traffic, and then I guess like AWS and specific ones. And then with Nomad, we would use console for load balancing Ingress. Console has built-in load balancing. You can use a feature console called Console Connect with Envoy for Ingress, and the Nomad job, this would be in a proxy stanza. I don't have experience using Console Connect, though it looks really awesome, and I would like to use it in the future. And then you can use other load balancers in Ingress, so like Nginx, HashiProxy, Fabio Traffic, and like traffic like integrates with console in that it uses console's catalog essentially to find what services to handle routing for. Okay, and then just briefly, secrets management. So Kubernetes, there's a secret object and you can store secrets in the volume. I've used HashiCorp Vault in the past with Kubernetes to store secrets. So I just included that here. And then secrets are consumed by pods, referenced in the pod spec. And yes, in Nomad, we would use Vault to store secrets, and then these are consumed by tasks in a Nomad job in a template stanza. All right, so I'll go into some of my personal reflections about Kubernetes Nomad and learning Nomad after Kubernetes. So this is just my own opinions, and I'm not disparaging either. So for me, yeah, it was simpler to get started with Nomad because I could set it up locally pretty easy. So I just needed to download the agent binary and then run it just on my laptop. So that was neat. Didn't have to download a whole bunch of things. Minicube's pretty large to just get started with something new. And yeah, so another thing, the mindset change was tricky for me because Kubernetes is really robust, has a lot of features, and whereas Nomad and the other HashiCorp tools are more single purpose. And so I kept trying to compare Nomad to Kubernetes when I was first learning, and it got me pretty confused since they're not like one-to-one, right? Yeah, and additionally, I was learning console and other tools at the same time. So it's learning a variety of these single purpose tools and then having to put it together, like how they interrelate and how to use them together was a little tricky. So something else I realized too is like I used Helm a lot when I was using Kubernetes, and there's lots of layers of abstraction with Helm and Helm charts. So I was like building and using Helm charts heavily, and I'd say Nomad job specs are simpler than raw Kubernetes config. So that is something I forgot about, and I just like realized recently. I'm like, oh, okay, if I were just to write all of these out, all these config out, it's a lot more than just adding values I need to a YAML file for a Helm chart. And that said, I would like a Helm-like solution for Nomad, mainly to be able to have reusable common config, common ways to deploy specific applications or recommended ways to quickly and easily spin up particular ecosystems or things that are run together usually. And so yeah, Nomad is a smaller ecosystem, but I'm excited to see what comes out of that. Okay. Hope those takes are not too spicy. And now we're going on to the Nomad cluster. So I'm going to show you, talk about how you get started with Nomad essentially. So how to set up your own Nomad dev cluster. Go to Nomad website and you download the binary and you add it to your path. And that's pretty much it. Then you start Nomad. If you're running in dev mode, this case, Nomad agent dev. So Nomad agent is the command to start Nomad, and you can give it various flags to define where your config lives, etc. And if I wanted to view the Nomad UI, Nomad comes with a UI built in. So I would type in Nomad UI, and then that would open up in my browser of choice. And to check the status of the Nomad agent, I would use Nomad agent info. So that's, yeah, Nomad agent info is like a basic cluster operation command. And so when you start in dev mode, in the foreground, it'll be log level debug. But let's say you need to monitor or you have an issue with your production cluster remote, you can set the log level to debug and see like what's going on with your agent that's running on a node or the server. Then for Nomad process metrics, you use a Nomad operator metrics command, and then pretty just makes it like human readable. And Nomad resource status. So if you do type in Nomad status, you can see what jobs are running or what allocations are running on your cluster. Okay, so let's talk about Nomad jobs. All right, so here we have a job stanza or job spec for this HTTP echo application. So what it is a simple Go web server that echoes whatever text input you feed it. So this is what the complete job spec would look like, and we'll go into the different parts of it next. Okay, so first we talked about tasks earlier, and so here's the task stanza. Here we're saying this task is called web. We're setting the driver to Docker. So we're saying, hey, we want to use Docker for this. And then in the config, we're using the host network mode. So we're using like Nomad's built-in network. We're not going to be using console for this demo. So we would have a different network mode in that case if we were. And so we're using a Docker image. So this one is a HashiCorp HTTP echo image. And then we're providing arguments to it. So we want to listen on port 8080. And then we want it to output hello world because this is our first Nomad job that we're deploying. Additionally, we're setting the ports. Next is the task group stanza, so which actually includes the task, but I'm just highlighting the unique part of the group. So this is where we set the count. So in this case, I want one task to be running, one of the web tasks to be running. And then we also define the port we want to expose. And then the job stanza, again, job is the entire document here, but I'm highlighting the unique part of the job. So this HTTP echo job, we're setting what data center we want to use. So in this case, the default Nomad one is DC1. And then the namespace we want to use, so we're using the default namespace, and the type of job we are running, in this case, type service, which is also the default, so including it here. Okay, so we'll just go through some basic Nomad commands relating to jobs. So to deploy a job, you do nomad run, and then you run the job spec file. So in this case, we named it HTTP echo.nomad. And then to check a job status, you use the nomad job status command. And to get logs for the task, we do nomad alloc logs. And then say what job we're using or we'd like logs for. The nomad alloc command is super helpful. There's more that you can do with it other than logs. So I recommend taking a look at that later if you're curious about running Nomad and setting up your own job. Okay, additional commands. So if you wanted to restart the allocation or the task, Nomad alloc restart. If you're wondering about your job history, so if you want to see like how it changed, you can use the nomad job history command. And if you want to stop the job, you just nomad job stop and then provide the job name. Okay, so we go into demo portion. So I'm going to deploy the Nomad agent in dev mode and then interact with the cluster and also via the cluster UI. So you can get a chance to look at what that looks like. And then we'll deploy a Nomad job and we'll interact with the job. Okay, so I'm going to share my screen. All right, Toby, how does that look? Do you see a command line? Okay, I think
Yep, seeing it.
That's okay. Okay, so first we're just going to start Nomad. I don't have this Nomad binary in my path for reasons, so I'm gonna go Nomad agent dev and run it in dev mode in the foreground. So this node configuration file is loaded. I didn't provide it any custom config, but you can provide that at start time. Okay, so I think this is up and running, so I can go Nomad UI, and then let's see. Okay, so this is Nomad UI. As you can see, we have no jobs running. Our cluster is empty. It's pretty handy UI. You can look at your clients and server information. So if I wanted to inspect further, I can look at, this is all just running, on my machine right now. And okay, so we'll go ahead, deploy our first job. So HTTP echo is similar to what we're showing in the slides. And we're gonna output hello world in the browser. And we're gonna have one task running. Okay, so let's deploy. We say nomad run HTTP echo.nomad. Okay, so let's see. Nomad status. Link this searcher. Okay, I ran nomad status, and I can see that the HTTP echo service is running. Let's see what are the other commands that we can run here. So I can say a nomad job status, HTTP echo. Another command we can run. So this provides me information such as like the name, the type, priority, and so on. And the status, successful, deployment completed successfully. That's great. And there aren't logs for this, but if I wanted to tail the logs, I would say nomad logs. Yeah, there's no logs. You can also just like follow the logs too. Okay, so let's see, we can probably see. Yep, go back to the Nomad UI, and we see our HTTP echo job running. So you can interact with it here too. One place, one desire, one healthy, great. You can see the task groups. So we wanted one, these tasks running, and that's what's running. Now we're looking at the task group. We can see also resources reserved for the task. Okay, so this is not very CPU or memory intensive task. So we can look at the allocation and see more information about the resource utilization here. And this should show us what we want to see. So output of this app is hello world, as we told it to. And this is dynamically, this port here is dynamically allocated by Nomad. You can specify ports as well, but in this case, this was dynamically allocated. Okay, so let's see some more cluster interaction. Okay, so let's see what we can find out about this Nomad agent. Okay, a lot of information. So client information, client health, leader address. And in this case, since I'm running this locally in dev, this is, I believe it's running as server and client. I might be wrong here, just server in this case. But yeah, you wouldn't want, typically you don't want your agent running in client and server mode. Okay, let's see. Let's say Nomad operator metrics. So there's more information about the host and whatnot. Yeah, and there's the Nomad. Did we run this already? Nomad status. Yes, yeah, that we have our service up and running. Let's see what those jobs history is. Job history, echo. Yeah, so we just deploy this. So we don't really have any history, but you would be able to see information about changes using the job history command. And if I wanted to stop the job, say Nomad job stop. And we can go look UI, you can see our job stop. And yeah, that's it. I just wanted to provide just basic demo. All right, any questions? Toby?
Yep. All right. Hello, guys. I'll be helping Iris out with the Q&A here. Got a few great questions from you guys. So one of the first ones is, would you be able to share the slides with me? I'll have to double check if we can send out slides to individuals, but we will be creating a resource page for this webinar, so you guys will be able to check in again on our site. Expect that to go live in the next day or two. And now for the questions. First one, Iris, is there a one-to-one connection between one server and only one client, or one-to-many?
It's let's see, I'd say one to many. So it's not like one client only communicates with one server. The requests are forwarded from clients to servers, and I believe it can be any server.
Cool. And then the next question is, how about persistent volume handling and configuration handling like config maps?
Yeah, that's a good question. Let's see. Actually, I'm not super sure the answer to this. I think I'm more familiar with Vault handling information than I am Nomad for persistent volume. So it's a good question. I will say I'm not the expert at either of these two technologies that I've used them.
Cool. And the next question we've got here is, how are allocations different from tasks?
Yeah, that's a good question. So let's see. That's a good question. I am actually not 100% sure on the answer.
Move on to the next question here. We've got, can you use something like Open Policy Agent on Nomad, or does Nomad already have something like that built in?
Could you describe what Open Policy Agent is? I don't think I'm familiar with that.
Yeah,
for the asker.
Pop that into the chat, feel free. In the meantime, we can move on to the next one here. We've got quite a few coming in. Is there any way to scale jobs on Nomad?
Scale jobs. That's a good question. Typically, you would scale the groups and not the job. So you would have one job, let's say, for a service, and then you would define, let's see, or you can define multiple tasks within the group in that job, or I believe also you can have more than one group in a job, though I've typically just used one job, one group, and then several tasks defined within a group.
Cool. And then the next question here is, what about security? How does Nomad compare with K8s when it comes to Nomad?
Yeah, for security, let's see, there's ACLs available for Nomad, which is not something we set up for the demo, but yeah, you can also configure, let's see, Nomad with Vault if you're looking to secure Nomad tokens, or also secrets that Nomad tasks will consume. So, and I know there's like ACLs available for Kubernetes as well. So yeah, you can set different policies to secure your cluster.
Cool. And then with that, what are the best practices to protect my Nomad cluster?
Yeah, good question. Yeah, use ACLs to, if you're like sharing access across your organization, to like limit who can access it, and then probably don't want your Nomad UI on the public internet, or be able to access that without using VPN of some sort. And yeah, keep your secret. You know, use Vault would be a good way to do that. Let's see, other ways to keep it secure. And then just general, you know, best practices for your tools, right? Just these privileges all around. ACLs can help with that.
Cool. And we've got one more question here. We've still got some time, so if anybody else has more questions, feel free to keep popping them into the Q&A chat box there. Oh, yep, got a few more coming in. All right. So next question, what are the limitations of Nomad when compared to K8s?
Yeah, good question. This is a good question. There are definitely a few things that I would like to see implemented. And I think one of those things is being able to see, and if there's any Nomad folks, please correct me if I'm wrong, to see like desired, kind of more like desired number of allocations with like actually ones that are up and running. I think that on the command line, I don't know if there's like a way to do that, or it might be incorrect about that. I think auto scaling for tasks, I think is an area that needs improvement. But yeah, again, Nomad is single purpose. So I think sometimes too, sometimes docs are hard to find, because if you need multiple systems working together and they're in different places, that's something that tripped me up sometimes.
Cool. And got another question here. Can we get any documentation or documents on the Nomad configuration part?
You're looking, can you repeat that, Toby?
Yeah, it's can we get any documentation on the Nomad configuration part? I don't know if we might have resources on our site already. You might know better than me, Iris.
Okay, yeah, and there should be documentation on the Nomad site. There's also HashiCorp Learn platform, which offers different tutorials, but there's, let me see, Nomad. Let's see if I can go to the site right now. Yeah, if you go to nomadproject.io, there's docs, and then there's API docs specifically. So depending on what you're looking for, you may have to click around a bit, but they're available.
Cool. And I'm seeing quite a few more questions come through. People are asking, is this session recorded? It will be, and we'll be posting it on our site in the next day or two, so you guys will be able to refer back to this one there. Okay, we got another question come through. Let me type it in for you. What is one thing you wish you knew about running a production fleet of containers, either relating to Nomad or just K8s in general? We are looking to move to containers, so just beginning our journey in this space.
Yeah, good question. And Toby, could you type that out so I could get there? Okay, thank you. Yeah, so what is one thing I should know about running production fleet of containers, either relating to Nomad or Kubernetes, looking to move to containers, so it's beginning of our journey. Yeah, so if you're, it's easier to go to do greenfield. So if these are like brand new applications, it's easier to spin up and with either Nomad or Kubernetes. If you have a larger, let's say you have a large monolith that you're trying to chip away into microservices, and that can be trickier. So something I wish is, because having done that, Nomad would have been a good candidate for that, because you can use Nomad as a workload orchestrator for like other services, right? So like other like VMs, etc., and for containers too. And so I feel like that would have helped so much more with networking. If you are breaking apart a large project into smaller pieces, being able to still have a cohesive feel for end users can be tricky. So I think that I wish I knew about Nomad for that sooner, though maybe it wasn't ready for use like that when I was using Kubernetes to do that.
Cool. Another good question here. So why should I favor Nomad over a cloud-hosted container orchestrator such as ECS or EKS? What are the real benefits?
Yeah, if you want to, it just depends on like what your needs are, really. Like if you're looking to orchestrate more than containers, which a lot of folks have like mixed environments, then definitely Nomad would be beneficial in those situations. Yeah, it's just like really like it depends, right? So without knowing all your team needs, it's hard to say either way. But just as a general purpose orchestrator, it's really helpful.
Cool. And I think that might wrap up all of the questions. Anybody else, if you've got any final questions, feel free to shoot them into the Q&A. We've still got a little bit of time here.
Oh, I see Eric's comment. Yeah, we're decomposing a monolith, which seems to be taking forever. It's really hard. I've been there. Yeah, I would say that you might, if you want to give Nomad a shot, you might be able to at least network them together better, because it's hard to just flip the switch, right? Just like completely switch over into to microservices, like containerized microservices from some existing system. So if you're interested in trying Nomad for that use case, I think it should be helpful. And I just want to say thank you to Toby, and then also to Chang Li. She couldn't be here, but she was super instrumental in getting this together. So just want to give a little shout out.
All right. I think that might wrap things up for today then. Just like to reiterate again, this webinar was recorded. We'll be posting it on our site under one of our resource pages for the event. So keep an eye out for that within the next day or two. You guys will be able to look back at the entire webinar, the entire Q&A, and all of the slides as well.
All right. Take care.
All right.
Thank you.
Thank you, everybody. Have a great rest of your week.